Let's talk about the basics of iteration. Don't worry if you don't know what iteration is. We're going to talk about that. So how do you iterate through a container? All right, well, let me show you a container. Here is a container. It's an array. So how do I iterate through that array? Well, the very first thing you're going to say is, well, what does iterate mean? That sounds like one of those words, Tanya, that software people use that I need to know what that means. Okay, well, yeah, you do need to know what iterate means. So what is it? The action or a process of iterating, or what's the word? Repeating. Yeah. As a procedure in which repetition, see, repeating, repetition, of sequence of operations yields results successfully closer to the desired result. So we're iterating, we're going through and repeating, and we're working towards a desired result. So therefore, we're repeating operations over and over again, trying to get to a desired result with each iteration as we move around. The repetition of a sequence of computer instructions, okay, operations, instructions, see those two words are the same, a specified number of times or until a condition is met. It says to compare recursion. We're not going to talk about recursion now. That's more of an advanced topic. So we'll cover that later in Dev School. One execution of the sequence of operations. Okay, so we've iterated. We have one execution of the sequence of operations or instructions in an iteration. Let me look at one more. It also says to do, to say or do again and again and again. Oh, okay. What do you see that's common here? We see again and again and again, repeating. We see operations. We see repetition. We see instructions. And we see that it continues a number of times or until a condition is met. It's a loop. Oh, okay. That makes sense, doesn't it? So how do we iterate through an array? All right, well, here's our array. Now let's walk through this. All right, so we need to set the pointer position to 0. So first we have to start at the first element. Got to have a starting point. Then we fetch the key and data value out. All right, so we're going to take a look at this. What's the key? We're at the first element. What's the key? Come on. 0. We're going to pull out that data. So there's the data from that first element. See that? It's this right here. This is the first element, this guy right here. All right, so we pulled that down. So now I've got the data, which is also called value in some languages, and the key, which can also be called an index. And now what do? Well, now we go and do some work. Well, that makes sense. I pulled this information out of the container. Now I want to go do some work with it, right? Okay, what's next? When done, then I'm going to compare something. I'm going to ask myself, if I'm Mr. Iterator, the number of elements. So how many elements do I have in the container? I have 1, 2, 3. I have 3 of them. Is that greater than the pointer's position? Well, here's my pointer's position. It's at 0. And we know that this is indexed at 0. So this would be 0, 1, and 2. So is this greater than 2? No. If yes, then increment the pointer's position. So we're going to go down to the next one if yes. So let's do that. Now we're pointing at the next element. If no, stop. That if no is important. Because watch what's going to happen. Ready? We're going to come down here. We're going to say, all right, now loop back around. Go to step number 2 and repeat. And it's just going to keep repeating until this conditional is no longer met. So the number of elements is not greater than the pointer's position. Then I'm going to stop. All right, so what's needed to iterate a container? Think about it. If I have an array, what's going to be needed to iterate that container? Well, I need some built-in functionality. All right, so here we go. Ready? It's time to put on our thinking caps because it's thinking time. I want you to think about this. Let's think about what we really need to iterate. What do we need to loop through a collection? Well, we need a pointer, right? So the collection itself needs a pointer. It needs to be able to say, hey, you're right here. And then we need some functionality to be able to do the actual iteration sequencing. We just went through the steps of what the sequence is. So that's the functionality. The pointer is the data value. It's telling me I'm right here. So it's some sort of reporting back of an attribute. It says this is where I'm at. So I've got functionality and I've got data. Now, where should this functionality be? Think about it. Should it be separate or part of the collection? It should be separate. All right. Now you're going to sit there and you're going to go, okay, why? Well, if you look in code, you'll see that the array needs different types of functions that then iterate through it. It's not built in, right? There are for loops, there's while loops, there's pointer resets, there's all different types of things to be able to work with the pointer within an array and be able to move that pointer around and pull data out. So why is that functionality not built right into the array? Why is that? All right, let me give you an example. So when you're hungry, every time that you're hungry, every single time you have to get into your car, right? And you drive to the grocery store, and then you pick up the food that you want at the grocery store, and then you come home and you prepare that food, and then you put it on your table. So every single time you're hungry, these are the steps you have to go through, right? This is what you do every day, 3-4 times a day when you're hungry, right? Well, no, of course not. You go to the store, you buy your food, and you put that food away. So therefore, let's back this up. So now I can say, no, I don't need the store, and I don't need driving to the store to be directly coupled to when I want to eat, because I'll do that in advance and I'll have some food in the house. So therefore, my hunger does not need to be tied to getting in the car and driving to the store. I have some food in the house. We call that decoupling or decoupled. Hey, that's one of those words you should know. So get out a pen and paper. Write that down. That's one of those big scary words. One of those software words that you should know. Decoupling. And that's the premise of abstraction. We're going to learn more about abstraction. But that's the premise of getting in the car does not absolutely have to be associated with putting food on the table at that moment that you're hungry. Going to the store does not have to be directly coupled to putting that food on the table right now because you're hungry. Because instead, you can go walk to your kitchen and go grab something out of the refrigerator and eat it. Yes, there are times when you have to go to the store to put the food in the refrigerator. But that's a separate thing. When your refrigerator doesn't have food in it, that's a trigger to say, a conditional to say, hey, go to the store, silly, you need some food. Do you see the coupling there? We have now decoupled that activity. Well, how about preparing the food? Well, that's loosely coupled. Why? Because some food can be prepared ahead of time. It can just be sitting there in your refrigerator, or some food does not even need to be prepared. A lot of what I eat is fruits and vegetables. I can just go in, wash them, and eat them. That's it. I don't have to prepare. And in some cases, I've already got it pre-prepared. It's already washed up and just sitting there. I just walk in and I grab an apple or a banana and I'm on my way. I'm hungry. I just go grab some food and walk away. That makes it loosely coupled. So hang on to those terms. We're going to be working with those terms all the way through your training. It is terminology time. Coupling. That's the act of combining two things. So therefore, decoupling, we can say, is the act of unlinking two things, separating two things from one another. And why is that? In software, you want to be able to swap out the implementation. Driving to the store is an implementation. I don't need that every single time I am hungry. It also reduces complexity. By decoupling those pieces, those elements, I can now say, I can just focus on, I'm just hungry. I just go and I get something to eat. I'd spend a lot of gas money and a lot of time every time I want to go and grab a banana that I got to run to the store and go buy one banana. It promotes reuse too, because now these two are separated from one another. So in code, think about that. If we wrote everything all in one great big subroutine or one file, or even we had several files, but they were so tightly coupled together, I couldn't separate them, could I? I couldn't separate the comments from a blog post. Those are two separate objects, two separate things. Yes, they have a connection to them, but it's loosely coupled. And they don't need to be directly connected. I don't have to have comments for a blog post to exist. So it promotes reuse. A change in one module is not going to affect other modules. It doesn't cause that ripple effect. Think about that. When you're programming, if everything is so tightly coupled together, when you make one change in your code, it has this cause and effect, doesn't it? It just kind of ripples through your code. And you go, darn, I changed this one thing over here, but now that's not working. Oh, and I got to change that too. Oh, and now the meta's got to change it. Oh, now the title's got to change. And I got to change my SEO. And now I got to change the comment side of stuff. By decoupling and putting these into module-based programming, then I can say, here, I just built this suite of tools. So I just built code just to handle the blog post or just to handle the meta for the blog post. I have one that just handles comments. I have one that just handles widgets. I have one that just handles some of these sidebars, and I start breaking that up into modules. It promotes reuse. It breaks down the complexity. I can start to go, okay, well, I need comments for this other project. I'll pull this module and I'll put this in. I don't have to tear code apart to be able to just pull out just the comment stuff that I need because I've written that in a module. So I want to tell you, congratulations. You just learned a key software and quality principle. Good job. We're going to go through. There will be courses, lots of courses on software and quality principles, including standards, terminology, and so on. This was just a brief introduction, and every time one comes up, we'll introduce you to it, okay? What are the takeaways? Iteration is repeating a sequence. It's a loop. We want to separate the iteration functionality from the container. The container is the data. It's the stuff that we want to evaluate. But the actual iteration functionality gets decoupled from that data. So now I'm able to come in and actually look at objects. I can look at other types of containers. I can look at arrays. I can look at collections. I can do lots of different things with iteration. So I'm swapping out the specific implementation and pulling myself away to be able to say the functionality of that is separate. It's decoupled. And we're going to go through that, walk through it in practice in the next topic.